In our next section, we're going to talk about the Easy VPN feature that is used for remote access IPsec VPNs both on the iOS and on the ASA. For the iOS, we're going to look at the Easy VPN server configuration in a couple different variations using the original implementation using dynamic crypto maps, which could be considered the legacy mechanism today. The new implementation of this using the dynamic virtual tunnel interfaces, or DVTIs, along with the ISACamp profiles, the Easy VPN server configuration on the ASA, and then the iOS Easy VPN client configuration, both in client mode and in network extension mode. Now, the overall goal of this feature with Easy VPN is that we're going to be creating an IPsec tunnel that is on demand, or that is dynamic, meaning this is going to be a remote access VPN. Now, one of the key points about this, different than what we previously saw with the LAN-to-LAN VPNs, is that the responder who is receiving the IPsec session doesn't already know what the IP address of the initiator is going to be in advance. Where with the LAN-to-LAN configurations, with the crypto maps, with the static virtual tunnel interfaces, and with the tunnel groups on the ASA, we saw that we were always manually defining the peer addresses inside the crypto maps, or manually defining the peer addresses inside of the tunnel groups. But with EasyVPN, the server is essentially going to be listening dynamically for a connection to come in, then based on different phase 1 and phase 2 parameters, is going to offer different services down to the client. Now, in order to accomplish this, there's going to be two main portions, or two main components of EasyVPN. The first of which is the EasyVPN client. This is the device, whether it's the software client running on like your Windows or your Mac OS machine, or even on your phone. This is the device that's going to initiate the IPsec tunnel. Then we have the EasyVPN server, which is the IPsec responder. So the device receiving the tunnel, which is either going to be the iOS or the ASA running in the EasyVPN server mode. Now, in order to negotiate the EasyVPN tunnel, we're going to start with our normal phase 1 ISACamp parameters first. So things like the authentication type, whether we're doing pre-shared authentication or RSA signatures, the encryption, whether we're doing single DES, triple DES, or AES, the hash, either MD5 or SHA, and then the Diffie-Hellman group to determine how we're going to generate the keying material for our encryption and decryption keys of the actual encryption algorithm. In addition to this, the client is going to send a group name that is ultimately going to determine what is the client's policy that the server is going to offer it. So we have our normal phase 1 parameters with the addition of this group name. Now, if the group authentication is successful, then the server is going to offer different types of options down to the client, like a new address for the tunnel, maybe a split DNS server address, a WINS address, maybe split access list settings that are ultimately going to control what traffic does or does not go over the VPN tunnel, where all of these settings are negotiated by what we consider ISACamp phase 1.5 or 1.5. Now, we mentioned this phase 1.5 briefly before, where it's made up of two subportions that are known as mode configuration and extended authentication, or mode config and XAuth. Now, the mode configuration portion of ISACamp is an extension of 4 new messages that are the configuration request and reply and the configuration set and acknowledgement. Essentially, what these new messages are used to do is to ask or request for different attributes and to set or reply with different attributes. For example, the client could ask for an IP address, and then the VPN server with mode configuration can reply with a local DHCP address, or could forward it to a remote DHCP server or a remote radius server. In addition to these mode configuration options, we have what's known as XAuth or extended authentication, where with our normal ISACamp authentication, we are only doing authentication to the device. or in other words, doing the group-based authentication. Where extended authentication is going to do a two-factor authentication. Authentication for the group and then a per-user authentication. So what this would allow us to do is to have a shared group username and password, then individual per-user authentications through protocols like CHAP or even the RSA secure IDs, things like one-time password tokens. But once the user authenticates, we could say on a per-user basis, maybe I want to assign them from this specific IP address pool. Or user 1 is going to get a different DNS server than user 2. Or user 3 is going to get a different VPN filter that is going to apply onto their tunnel as opposed to someone else's. These are typically the options we saw on the ASA when we looked at the output of the show run all group policy, where these individual options are going to be assigned through mode configuration once the extended authentication phase has completed. Now, in addition to having these new forms of negotiation of the tunnel, the EasyVPN remote, which is the client or the initiator, is going to support two different modes of operation. The first of which is considered the client mode. Now, the client mode is what we would typically think of when we're thinking of the end VPN client that's running on your Windows machine or that's running on your phone. This is when the EasyVPN server is going to assign a new IP address to the client. Then the client is going to run a network address translation and port address translation to this new IP address when traffic is sent over the VPN tunnel. Now, the second option we have is what's known as the network extension mode, or NEM. With network extension mode, the difference is that we do not have a new address assigned by the server, and the client is not going to perform network address translation or port address translation. And sometimes this type of design is called the hardware client, or EasyVPN remote hardware client, where the idea of this is that network extension mode is functioning more like a LAN-to-LAN tunnel, but yet it is still an on-demand dynamic tunnel, where the EasyVPN server is not going to initiate the connection down to the client. Client is always going to be the initiator, but once the tunnel is up, we can send any type of packets bidirectionally, where with the client mode of operation, since we're running port address translation, there's going to be an issue with someone on the server's side who is inside of the VPN trying to access services that are on the client's side. Now, typically with network extension mode, it's called the hardware client because you would have some sort of dedicated device that's doing the VPN connection on behalf of the rest of the network. Now, if we were to look at our topology here, and we're configuring, let's say we have router 3 configured as the EasyVPN server. And we have two types of clients. One that is on the end client on the PC. This one is going to be running in client mode. Where router 5 is a hardware client that is running in network extension mode. Now, the difference between these is that when the client or the test PC is connecting to the VPN server, we're going to be allocating it a new IP address. Let's say that we give it the address 172.16.255.1, where the address that it is assigned on the LAN is 192.168.118. But for any traffic that is going over the VPN, we're going to do a port address translation that goes to this new 172.16 address. Now, the problem with this is that if there's someone behind the test PC, let's say that there's an IP phone, then there's going to be some issues when we try to send a connection from the outside in to this client, because we know that the network address translation table works similar to a stateful firewall, where traffic is generally allowed from the inside out and then to return, but it is not allowed from the outside in unsolicited. And this is what the network extension mode is going to solve, where if router 5 was running network extension mode, we are not going to be assigned a new address. Then anyone who is behind router 3 would be able to reach someone on the 10.0.56.0 network or the 10.0.6.0/24 network without having to go through any type of network address translation. Now again, in our case, we're going to look at a couple different examples of this design where we will have one of the iOS routers run as the EasyVPN server. Then we will have two different types of clients. We'll have the software client on the NPC, and then also the iOS as the client. We'll have the ASA as the VPN server, and then likewise have both the software client and the iOS as the client. Additionally, for the iOS server configuration on router 3, we'll see there's a couple different variations of this. One that is using the dynamic crypto maps, which was the original configuration logic for this. Then the newer logic that is using the dynamic virtual tunnel interfaces, or the DVTIs. Regardless, for all of these configurations, whether we're doing it on the iOS or the ASA, we'll see that there's a lot of individual syntax options that we need to apply. So just like some of the previous VPN configurations we saw, this is definitely one of the ones that you want to know where this is located in the documentation. Now, we saw on the ASA that we could look at the show run all tunnel group, the show run all group policy, and the VPN setup command. That's going to help us to get some information about what the syntax is supposed to be. But for the iOS, generally, we're going to be relying just on the configuration portion of the documentation.